Hey everyone, this is the second lesson in actuarial derivative pricing, and today we're going to look at payoff functions and put call parity, in particular the European type. So what this means is that they can only be exercised at the maturity date, capital T. So let's look at some basic terminology first. Simply, capital T is the maturity date of a derivative, capital S, lowercase capital T, is the stock price at the time of maturity date, capital T. Capital S lowercase t subscript is a stock price at any time t, and capital K is a predetermined strike price. So let's first look at a payoff function at the maturity for buying a European call option. So in this case, you're buying the call option and then therefore you have the right to buy the stock at the predetermined price at the maturity date. Yep, so as you can see, the capital C and in brackets with the stock price at maturity date and the maturity date is equal to the stock price at the maturity date minus the strike price in brackets, but we're only looking at positive values. So if it's negative, what this bracket and subscript positive sign means, it just means that it will go to zero. So any negative value will stay as zero. And again, we'll see why in the next slide. So we have the payoff function, and this is for a call option. And I reiterate again, the buyer has the right to buy the stock. So let's look at this example. So a stock price is $5 at maturity date, and the strike price is $10. So what this means is, if you're the buyer, then you have the right to buy a $5 stock at $10. Would you do this? And the answer is no, you wouldn't. Therefore, you wouldn't exercise your right, and therefore have a payoff of $0 because you did nothing. Again, if you plug this in the equation above, you'll get -5. However, since it's in the brackets with the positive subscript, this goes to 0. So therefore, you see, it works with the formula. Again, let's look at the second example. If our stock price at time t is $10, our strike price is $10, which means we have the right to buy a $10 stock for $10. Now, our decision doesn't really matter. Either way, if we buy the stock or if we don't, our payoff will be 0. And this again is congruent with our formula. Now, for a third example, what if the stock price was $15 and the strike price was 10, which means we can buy the stock for $10, but it's worth 15. In this case, we would exercise our right, and then we'd have a payoff for 5. Again, if we plug in the formula, we will get the same thing. Now let's take a look at the European put option at maturity. So again, instead of a C, we now have a capital P. And in brackets, we again have the stock value at maturity date as well as the maturity date. And what this means is it's just a payoff function for a purchase European put at time capital T. Again, this formula seems very similar, except all we did was we switched around K and capital S subscript T. So basically, we just swapped the stock price at maturity date and the predetermined strike price around. Yep, and hopefully that makes sense. And we will show you again with this example. So in this case, the buyer has the right to sell the stock. So if there's a stock, it's worth 5, whereas the strike price is 10. So the answer is, would you sell your $5 stock for $10? And the answer is yes, you would. So therefore, you exercise your right to sell the stock, and therefore your payoff is $5. Again, congruent with the formula. Now, if it's $10 stock and $10 strike price, you could sell your $10 stock for $10. Here, your decision doesn't matter. Whether you exercise or not, your payoff is $0. Now, the stock price is $15, and you have the option to sell it for $10 at the strike price. In this case, you obviously wouldn't exercise your right because you'd be making a loss. Therefore, you get $0. Again, it goes by the formula above. Now let's look at the forward contract to buy. So in this case, we're just looking at the party who has an obligation to buy. And yeah, again, so the payoff for a European forward contract to buy at time capital T, that is what the capital F is in brackets. So here we see a few examples that sort of explain how forward contracts work. So the formula is the stock price at maturity date capital T minus the strike price. Here, there is no right, there is no option to buy. Everything is an obligation. So as we see, in the same situation, if the stock price is 5 and the strike price is $10, it means we can buy a $5 stock for $10. Would we do it? Well, ideally not. However, because this is a forward contract, we actually have no choice but to buy. Therefore, we have to buy the $5 stock for $10, getting a -5 payoff. Similarly, if it's $10, we'll have to pay $10 for it and therefore have a payoff of 0. And if it's $15, again, we'll have to buy it for $10, even though it's a good choice and our payoff is $5. So now we'll look at the payoff function for any time t for forward contracts to buy. So this is very similar to the last one, except now instead of looking at just the maturity date of capital T, we're looking just for any time t. So this is very similar to the previous equation, except we multiply the strike price by the value of a zero coupon bond at time t with the maturity date of capital T. The reason we do this is sort of to discount the strike price. Reasoning behind this is so we don't cause an arbitrage, because what you could do is you could invest the strike price into a zero coupon bond, earning interest on that at maturity, and therefore create arbitrage. But by factoring it in when calculating a time t, this makes sure we hold by the no arbitrage rule. Now we look at the put-call parity. This is a very important formula and will come very useful. Again, this only applies to European options. It does not apply to American options. That's why we've been dealing in European options so far. Again, you can see the three equations we developed in this video so far. Simply, if you plug them in the equation, you'll realize that they are equivalent. Again, pretty much there's a more detailed version in the table below, but if you're not, rest assured that that's true. You can just look at the table in your own time and sort of figure out why this works and is the case. Yep, so in actuality, there's a more general put-call parity formula. We've shown how it sort of works at the maturity date, capital T, but in reality it actually works for any t less than the maturity date, as we can see here. And this put-call parity still holds, and it becomes very useful in many different calculations. Okay, so what we did is we covered the payoff functions for calls, puts, and forwards, and then we linked them together with our put-call parity. In the next video, what we're going to do is we're going to do some examples, some practical examples, because that really helps learning. In particular, just with put-call parities, putting together everything we've learned so far.